Okay, so let's start. We're moving into chapter 5. Today, we're going to talk about elasticity and its applications. So in this chapter, we'll talk about what is elasticity and what questions can be answered using elasticity. And in particular, we'll focus on price elasticity of demand and see how that relates to demand curve and how it relates to revenue and expenditure. Then we'll go to price elasticity of supply and see how that is related to the supply curve. Lastly, we'll talk about income and cross-price elasticities. So let's start with the story. So suppose you maintain social media accounts for some local company. So 小编. You charge $6,000 per business, and you're maintaining 12 social media accounts. Now, because you're starting to take classes in NTU, your cost is going up. Opportunity cost is high. So you're thinking, maybe I should raise the price to $7,500. Now, here's the question. From the law of demand, you know that if you raise your price, you will attract fewer customers. So you will not be maintaining 12 accounts like the current situation. But how fewer? That is the question. If you think of your revenue, would your revenue go up or would your revenue go down? So that is the question we want to answer. And here, this is where the elasticity of demand can help. Elasticity measures the responsiveness of quantity demanded, or in the case of supply, quantity supplied. How does that change to one of its determinants? So price elasticity of demand is how much the quantity demanded of a good responds to the change in the price of that good. And so in the textbook, it says, loosely speaking, it measures how sensitive buyer's demand is to prices. To me, price elasticity is precisely price sensitivity. It's the same thing. It's just that economists borrowed the term elasticity from physics. And so back in the days when economists hoped they could be the physics of social science. But for nowadays, if you don't understand the term elasticity, well, that's fine. Just replace it with sensitivity. That's exactly what it is. All right, so let's take a look. If the price goes up by 10%, quantity would drop. In this example, it's dropping by 15%. So the price elasticity of demand is the percentage change in quantity demanded divided by the percentage change in prices. So here, 15% divided by 10%. So the price elasticity of demand is 1.5. Here, because we're on the demand curve, price and quantity move in the opposite direction. So price elasticity is always negative. But for convenience, we know the law of demand. So let's just drop the minus sign and talk about the magnitude of price elasticity, or the absolute value. So, okay, the standard way to calculate percentage changes is the end value minus the start value divided by the start value. That's a percentage. So, for example, in the story that we talked about, you go from point A to point B, the percentage change in prices going from $6,000 to $7,500 is 25%. However, the change in quantity going from 12 websites to 8 websites, that's a drop of 1/3, 33%. The problem is, if you do the same calculation, But now, going from B to A, then the percentage change, so from 7,500 dropping down to 6,000 is a 20% drop. But the increase in quantity from 8 websites to 12 websites is 50%. And so you get a different price elasticity if you go from A to B, which is 1.33, versus from B to A, which is 2.5. That's a little bit problematic. And this happens because you use a different start values. And when the end value and the start value varies a lot, then you could have this problem. So how should we solve this? Well, a simple way is instead of thinking about the start value, use the midpoint, the average of the start and the end values. And so the percentage change is your end value minus the start value, but divided by the midpoint. In that case, going from B to A or A to B, the midpoint is always the same. And so you don't have a problem. And so, yeah, so it's relatively complicated, but you have this formula here. And of course, if you know calculus, or if you're taking calculus, you should realize that when you take the limit, when Q2 and P2 approaches Q1 and P1, well, it doesn't really matter anymore. Everything converges. Okay, but in this class, we don't need calculus yet. So we stick to the midpoint. So now let's go back to our story. Let's use the midpoint to calculate percentage changes. So moving from 6,000 to 7,500. So the change is 1,500. And the midpoint is 6,750. So this percentage change in prices is 22%. And quantity, going from 12 websites to 8 websites, you're dropping 4 websites. Divided by the midpoint, which is 10, it's a 40% drop. So the price elasticity of demand, in this case, is 1.8. Okay, so now let's try to do this. Use the following information to calculate the price elasticity of demand for iPhone 13 Pro. If the price is 32,900 NT dollars, quantity demanded is 10,600. And if the price is 50,400 NT dollars, quantity demanded is only 8,400. And then use the midterm to calculate the percentage change in prices, the percentage change in quantity, and try to calculate the price elasticity of demand. All right, so prepare to join the quiz. You're allowed to use a calculator if you need that. That's fine. Okay, so what is the percentage change in prices? So we have the 2 prices and 2 quantity. So is it below 0.2, equal or above 0.2 but below 0.3, or is it equal above 0.3 but below 0.4, equal above 0.4 but below 0.5, or equal above 0.5 but below 0.6, or none of the above? All right, so here are some of the answers. You might be still doing your calculation, but the majority say somewhere between 0.4 and 0.5. And the answer is yes, it is. Okay, what about the percentage change in quantity? Below 0.2 or 0.2 something, or 0.3 something, 0.4 something, 0.5 something, and so on. Okay, so we have like 5 seconds left, so please hurry up. All right, so the majority of you say 0.2 something. Let's take a look. Yes, it is correct. So given you know the percentage change in price and percentage change in quantity, what is the price elasticity of demand? Again, is it 0.2 something, 0.3 something, or 0.4 something, 0.5 something, or below 0.2, or none of the above? A lot of you said 0.5 something. Some of you said 0.3 something. Also, some of you said none of the above. Okay, so that's the answer. It is 0.5 something. So the percentage change in prices, so the endpoint is 50,400 and the starting point is 32,900. You have the difference dividing that by the midpoint, which is $41,650. Yeah, 42.02. Don't ask me why these numbers are so crazy. That's the prices that Apple posted on its website. Ask them. Okay, percentage change in quantity demanded. So the endpoint is 10,600. The starting point is 8,400. You take the difference, and then you divide that by the midpoint, which is 9,500. So it's 23.16%. Finally, the price elasticity of demand is the percentage change of quantity demanded divided by the percentage change in prices. So it's 23.16 divided by 42.02, so 0.55. So in the exams, you are allowed to bring a calculator, but you cannot use a calculator that has programming or memory function. Even if the numbers are like this crazy, that's fine. Now we'll look at how price elasticity of demand is determined. So to do this, we'll look at a pairs of examples and ask, suppose the price of both goods go up by 20%. Which good has the highest price elasticity of demand? And why is that? Okay, let's take a look. And of course, from these, you can learn lessons about what determines the price elasticity of demand. All right, let's start. First one, Samsung S21 versus the iPhone 13 Pro. Suppose the price of both goods go up by 20%. Which good does quantity demanded drop the most? Samsung S21 or the iPhone 13 Pro, or don't know? It's okay to don't know. Okay, you have 5 seconds, so please make your guess or make your answer. Okay, time's up. Let's look at what you guys think. So the majority of you say Samsung S21. Some say don't know. Some say iPhone 13 Pro. And the answer is the Samsung S21. So why is that? Okay, Samsung S21. Suppose the price is going to increase 20%. Are you going to buy it or not? Or are people going to buy it or not? And suppose the iPhone 13 Pro is now 20% more expensive. Are you going to buy it or not? Are people going to buy it or not? And the problem here is that, well, what's special about the Samsung S21? Well, it's a leading Android smartphone, but you can find other substitutes on the market that are also leading Android smartphones by other companies, by Sony, by Xiaomi, or by others. There are different varieties. So if the Samsung S21 is expensive, well, you can switch to something else. Here's the problem. Suppose the iPhone 13 Pro is now more expensive than the asking price that Apple is posting. Well, what would people do? iPhone 13 Pro has much less substitutes compared to a good Android smartphone. And so the increase in prices would not affect quantity demanded that much. Okay, so one thing we learned here is that price elasticity depends on whether close substitutes are available. So what do you mean by close substitutes? Well, the whole idea here is that if this is more expensive, what would I switch to? But an iPhone is an iPhone. Well, I can't very easily switch to something else. All right, next one. Mountain Dew versus soda. Suppose the price of both goods goes up by 20%. For which good does quantity demanded drop the most? Mountain Dew, soda, or I don't know? Okay, so time's up. Let's look at your answers. A lot of you say soda, 20% of you say Mountain Dew, and 8 of you say don't know. And the answer is Mountain Dew. Wait, do you know what is Mountain Dew? Yeah, so it's a particular type of soda that's made by the company that also is producing Coca-Cola. Okay, for Mountain Dew is a particular type of soda. So it's like Sprite, or in Taiwan you have 维他露啤 or 黑松汽水. That's a particular product. The key thing here is that if Mountain Dew, if this particular product is more expensive, what can you do? Well, switch to other brands. If Sprite is 20% more expensive, then you can switch to Heisong soda or other products. But if the whole category or a broadly defined good is expensive, now what can you do? Well, drink water or switch to wine or beer or something else. That's not easy. So in that sense, price elasticity is higher for narrowly defined goods than for broadly defined goods. So there's this difference here. So because for a narrowly defined good, well, if you don't have that, then you can switch to something else. But if it's a whole category and the whole category is more expensive, then you can't easily switch. Next one. Okay, prepare for this. Insulin and Dole, Rolex watches. If the price of both goods goes up by 20%, which good would have a larger drop in quantity demanded? Insulin, Rolex watches, or I don't know? Okay, you have 10 seconds to finish this question. Okay, time's up. Okay, so 35 of you say insulin, 24 Rolex watches, and 3 of you don't know. And the answer is Rolex watches. So, okay, what is insulin? Well, insulin is a necessity if you have diabetes. I mean, your blood sugar is always too high. You need something to help you. If the price goes up, well, would you say, no, I don't want to take insulin anymore? Well, you can. You would die if you do that. Compared to that, a Rolex watch is a luxury. So if the price is too expensive, we'll say, okay, I'll stick to my Casio or some cheaper watch. Okay, so here the lesson is price elasticity is higher for luxuries compared to necessities. Last question. Gasoline in the short run versus the long run. So suppose the gas price goes up by 20%. Does quantity demanded drop higher in the short run or in the long run? Or I don't know. So now it's the same good, but just thinking about the short run versus the long run. Okay, think about, can you easily switch? That's the key thing. Okay, so now let's look at your answers. The majority of you said the short run. Some of you say long run. And the answer is the long run. Okay, so the key thing is this. Does the quantity drop more in the short run or the long run? In the short run, if the gas price is going up, well, if you already decided, if you bought your car or bought your motorcycle, too bad. You have to pay a higher gas price, and that's it. Maybe you can say, oh, okay, so I'll leave my bike, I'll leave my car at home, and I'll take the MRT, or I'll take the bus, or I'll carpool with my friend. However, if you think of the long run, what you could do is you could say, hey, I might as well buy a smaller car, so I'll get a Toyota instead of a truck or an SUV. Or you could even decide that, hey, I might as well move to a place that's closer to work or closer to campus. If you live on campus, well, you don't need to ride your motorcycle to school every day. That would save you some gas money. So here, the key thing is that price elasticity is higher in the long run because you can adjust. In the short run, you're sort of stuck. It's too late for you to adjust, or not that easy for you to adjust. But in the long run, you can always start to switch, start to adjust. All right, so using elasticity, we can talk about different types of demand curves. We say demand is elastic if price elasticity is greater than 1. We say it's inelastic if it's smaller than 1. And if it's equal to 1, we say it has unit elasticity if it's exactly 1. If you go to extreme, you can think about a perfectly inelastic demand curve. That's when price elasticity is 0. You have a vertical demand curve. And you can also have a perfectly elastic demand curve. So you have a horizontal demand curve where the price elasticity is infinity. And graphically, the flatter the demand curve, the greater the price elasticity of demand. So let's show this in the graph. So this is a perfectly inelastic demand curve. So it's vertical. So if the price drops by 10%, quantity demanded does not change at all. Perfectly inelastic or perfectly insensitive. So you have a price elasticity demand of 0. So not sensitive to prices at all. If you're a Jobs fan, you love Apple products, well, you could be in this situation where your quantity demanded for iPhone 13 Pro Max could be completely unchanged of the price. That means you have perfectly inelastic demand. Of course, most people are not that extreme. You have a downward sloping demand curve. This one is what we call inelastic demand. So if the price drops by 10%, quantity increases by less than 10%. So you have a price elasticity of demand smaller than 1. So you're not that sensitive to prices. And you would have, if the price drops by 10%, quantity increases exactly by 10%, then you have a price elasticity of 1. That's unit elastic demand. And so you're sort of in the middle. And as the demand curve becomes flatter and flatter, you would have elastic demand, where a 10% drop in prices would result in an increase in quantity demanded by more than 10%. So you have a price elasticity of demand that's greater than 1, and so you are very sensitive to prices, a flat demand curve. And the extreme case is we have a horizontal demand curve where like an epsilon change in prices is going to give like a huge variation in quantity. And so you have a price elasticity of demand that converges to infinity. And so you are extremely sensitive to prices. If the price drops by 1 cent, quantity demanded just goes like crazy, increases like crazy. All right, so here are some real numbers. Price elasticity of demand for eggs, 0.1, healthcare, 0.2, cigarettes, 0.4, rice is 0.5, housing, 0.7, So these are inelastic demands. Beef, 1.6. Think of it, if beef is expensive, what would you do? Well, switch to pork or chicken or lamb. Peanut butter, 1.7. Well, what happens if peanut butter is so expensive? Well, you can have jam, right? Restaurant meals, luxury, yeah. Mountain Dew, 4.4. Actually, I got more numbers from Wikipedia. Rice in different countries, there's a variation. In Austria, 0.47, Bangladesh, 0.8, China, 0.8, Japan, 0.25, US, 0.55. There is variation across countries, but it's still, all of these are inelastic. Eggs. In households, 0.1. That's the number we saw in the US. In Canada, it's 0.35, South Africa, 0.55. Chicken, 0.5 to 0.6. Soft drinks. Yeah, we talked about soda. Soda in general, 0.8 to 1. So it's inelastic, close to unit elasticity. But for Coke, 3.8. Mountain Dew, 4.4. That's the number you just saw. The key thing here is that if Coca-Cola is expensive, well, you can switch to other soft drinks. But if the soft drinks as a whole is more expensive, it's hard to switch to something else. Alcoholic beverages. Beer, 1972. There's different numbers, measures. For wine is close to 1. Spirit, 1.5. So here you see that if the liquor is expensive, well, you can switch to something else. But beer is sort of close to like soft drinks, right? So the beer consumption is less sensitive to prices. Cigarettes, in general, 0.3 to 0.6. So cigarettes is addictive, so it's a necessity for the smokers, so they can't change. But one thing is that for youth smokers, it's slightly higher. Well, that means they're not that addicted yet, and so they still have a chance to switch. Transportation. Well, bus, 0.2. Yeah, so even if the bus prices go up, well, if you rely on the bus to commute, you can't go and buy a car the next day, right? So in the short run, it's not easy. But if we're thinking about a particular car model, like the Ford compact car, the price elasticity is 2.8. So if the Ford compact car is so expensive, I will go and buy a Toyota or a Honda or these other cheap brands. Airline travel. First class, that's a luxury, but apparently nobody travels first class that cares about money. So 0.3. If I think I'm the crazy rich Asian that I always travel first class, I don't care about the prices, so it's inelastic. Discount airfare, 0.9. So there you see a difference. Pleasure, for fun, for vacation, 1.5. So really sensitive to prices. Gasoline, we talked about that in one of the quiz questions. In the short run, 0.25. In the long run, 0.64. It's still inelastic, but in the long run, price elasticity is higher than in the short run. Medicine. So medical insurance, the price elasticity is 3.1. So not that many people would drop health insurance just because it's more expensive. If you look at pediatric visits, so this is bringing your young child to the doctor, it's essentially 0, 0.03 to 0.06. It's like 0. If my child is having a fever or needs vaccination, would I say, oh no, it's so expensive, I don't want to bring my child there? No, almost insensitive, completely, perfectly insensitive to prices. Gasoline is produced by oil in the whole world, 0.4. So even if the oil prices go up, quantity demanded for oil does not drop that much. Watching the movies, in general, 0.87. Live performance, 0.4 to 0.9. I do have these numbers are before the COVID pandemic. Now I think it's a completely different world, so we need new data. This is old data. For steel, 0.2 to 0.3. So even if the steel prices go up, would you decide to building without steel? Come on, I mean, that's impossible. So in that sense, steel prices have little effect on the quantity demanded of steel. Okay, so one thing to note is this. If you have a linear demand curve, the slope is constant, but price elasticity is not. Going from 0 to 20, the price elasticity is 5. Going from 20 to 40, price elasticity is 1. And going from 40 to 60, elasticity is 0.2. And the key thing is that price elasticity is sort of like slope, but it's the percentage change in quantity demanded divided by the percentage change in prices. So it's measured in percentage terms, not absolute terms. If it's absolute terms, then it's the slope. But it's percentages, so it's not. All right, so let's continue our scenario. So if you raise your price from 6,000 to 7,500, would your revenue go up or go down? And this depends on the price elasticity of demand. Your total revenue is price times quantity. So an increase in price has two opposite effects on revenue. You get higher revenue because of the higher price you charge, but you get lower revenue because you are now maintaining fewer websites. Well, because you're losing business. Your queue is going down. So which of these two effects is bigger? That would determine whether your total revenue would go up or go down. And here, this part depends on the price elasticity of demand. So let's take a look. So in the first scenario, well, your price elasticity of demand is 1.8. And so originally, you have a price of $6,000. Quantity demanded is 12 social media accounts. And the total revenue is $72,000. Well, substantial. Now, when you go to $7,500, quantity demanded drops to 8. That's how we did our calculation to get a price elasticity of 1.8. And so now your total revenue is only $6,000. And the key thing is that this shaded blue area is the lost revenue because you have a lower quantity. And it's larger than the shaded green area where it's the increase in revenue because of higher prices. And so that happens when you have an elastic demand. Yeah, so when demand is elastic, prices increase, causes revenue to go down. If you think of a different situation where you have an inelastic demand, so you go from quantity demanded of 12 to a quantity demanded of 10. So now the new revenue is 7,500 multiplied by 10, so that's $75,000. So here, in this case, so remember you have an inelastic demand, so you have a steeper demand curve. So the lost revenue due to lower quantity is smaller than the increase in revenue that caused by the higher prices. So that's the trade-off you have when you raise prices. And depending on the price elasticity of demand, if it's inelastic, increasing your price will cause revenue to go up. All right, so to summarize, if demand is elastic, if the price goes up, percentage change in quantity is greater than percentage change in prices. That's why elasticity is above 1. So total revenue goes down because the fall in revenue because of lower quantity outweighs the increase in revenue because of the higher price. But if demand is inelastic, so because the price elasticity of demand is smaller than 1, that means the percentage change of quantity is less than the percentage change in prices. So the fall in revenue is smaller than the increase in the higher price because of the higher price. And so total revenue goes up. All right, so now let's ask the question. Suppose the pharmacy is going to raise the price of insulin by 10%. Does total expenditure on insulin go up or go down? Suppose there's a price war, so the price of a luxury cruise drops by 20%. Does the total revenue of these cruise companies go up or go down? Now, let's start the quiz. All right, so pharmacies raise the price of insulin by 10%. Does total expenditure on insulin go up or go down? Total expenditure goes up, total expenditure goes down, or I don't know. So you have 10 more seconds. Please make your choice. Okay, here are your answers. The majority of you say the total expenditure would go up. Some of you say it will go down. 2 of you say don't know. And the answer, it's going to go up. Well, insulin is a necessity. So demand for insulin is inelastic. So when the price goes up by 10%, quantity demanded drops by less than 10%. So expenditure goes up. Would you stop taking insulin just because it's more expensive? Well, I mean, you'll die for that. Okay, next one. The price of luxury cruise drops by 20%. Does the cruise company total revenue go up or go down? Okay, time's up. Now let's take a look. So some of you say it would go up. More people say it would go down. And the answer is it will actually go up. So the key thing here is that because this cruise ride is a luxury, demand is elastic. So even though the price is going to drop, so that will reduce revenue, but your quantity demanded will go up, and it will go up more than the price drop. Because of that, your total revenue, the price effect is dominated by the increase in quantity, so revenue is actually going to go up. So you should know why a lot of these cruise companies constantly offer discounts, because when they offer discounts, actually the revenue could actually go up. Now we're trying to apply this to some policy. Think of how would the government decrease or try to reduce drug-related crime. So here there are 2 possible policies. One, let's increase the number of agents to the war on drugs. So you declare a war on drugs, you have more people to crack down these illegal drug dealers, and hopefully that would decrease drug-related crime. Okay, so here, because you're having more agents cracking down these sellers, the supply curve will shift to the left. And so what is the effect of that on drug-related crime? The other one is, how about let's go to the schools and do drug education? So this, you're going to reduce the demand for illegal drugs. You're going to shift the demand curve to the left. Question, which one would decrease drug-related crime more than the other? All right, so this is actually not a quiz. This is a poll. Does this policy increase or decrease drug-related crime? If you increase the number of agents fighting the war on drugs, would this increase drug-related crime, decrease drug-related crime, or make it unchanged? Or I don't know. Okay, so you're not really graded on this. This is a poll. Okay, so I see a lot of people making their answers. I'll wait for another 5 seconds. 4, 3, 2, 1. All right, so some of you say increase. Some of you say it's going to decrease. Majority of you say it's going to decrease. Well, let's take a look. So, okay, so let's look at the first policy. So this is the market for illegal drugs. The initial drug-related crime is the price times quantity. Here we're assuming that these drug addicts are so poor, they have to commit crime to get money to buy their drugs. Whatever money they get from these crimes, they always spend it on drugs. All right, so having a lot of agents to crack down the sellers, you're shifting the supply curve to the left. So you go to this new equilibrium, P2Q2, and the question is, does P2Q2 outweigh P1Q1? And we just learned, it depends on the price elasticity of demand. Well, the problem is that, well, drugs is an addictive good. Demand is inelastic. So the increase in price is going to outweigh the decrease in quantity. Counterintuitively, you actually have a larger value of drug-related crime when you try to crack down on these drug dealers. So it's counterintuitive, but the key thing is that you're addicted. So these drug buyers, even if the price is high, they still need to consume the drugs because they're addicted. So the only thing they can do is to try to commit more crime to get the money to buy the drugs. And of course, that's not good, but that's what's going to happen if you misunderstand that, hey, economics is telling you that, well, cracking down on the sellers, well, you might actually get a backfire. All right, so let's continue. So to conclude what we just saw, when you increase the agents devoted to the war on drugs, you're shifting the supply curve for drugs to the left. So that means higher prices and lower quantity. But because demand is inelastic, what you get is higher total revenue because the price effect is going to dominate the quantity effect, which means that you are increasing drug-related crime. So there's this backfiring going on. So instead, what could you do? Well, okay, so let's look at the other quiz. So suppose you have a policy of drug education. Would this increase drug-related crime or decrease or make it unchanged? You have 10 seconds left. Okay, so time's up. A lot of you say decrease, and that is the right answer. Okay, so think about education. So what you're doing is you're shifting the demand curve to the left. That means both quantity and price is going to fall. And of course, the total revenue is going to go down. So is drug-related crime. Okay, so to summarize this, so with this drug education, you can reduce the demand for illegal drugs. You shift the demand curve to the left. So you have lower quantity, lower prices, and so you are going to reduce drug-related crime. So, okay, so up to here, what we get is that you could have different policies to implement on your war on drugs, but some may backfire. Some may actually be good, be productive. Okay, so up to here, we went through the price elasticity of demand. Similar concepts we can talk about is income elasticity of demand. So this is how much quantity demanded responds to a change to the consumer income. And so it's the percentage change in quantity demanded divided by the percentage change in income. So we talked about normal goods versus inferior goods back in chapter 4. And for a normal good, income elasticity is greater than 0 because as income goes up, quantity demanded goes up. For inferior goods, income elasticity is negative. When consumer income goes up, quantity demanded goes down. Similarly, you can talk about cross-price elasticity of demand. So this is how much quantity demanded responds to the change in the price of another good. So it's the percentage change in quantity demanded of this good divided by the percentage change in prices of another good. And we talked about substitutes and complements in chapter 4. For substitutes, cross-price elasticity is positive. When the price of a substitute goes up, quantity demanded for this good would also go up. For complements, cross-price elasticity is negative. When price of a complement goes up, quantity demanded for this good would go down. So up to here is the elasticities of demand. Now, we can also think about elasticities of supply. So just like we have price elasticities of supply, just like we have price elasticity of demand. So price elasticity of supply is how much quantity supplied responds to the change in the price of good. So it's the percentage change in quantity supplied divided by the percentage change in prices. So again, it's price sensitivity, but it's the seller's price sensitivity. So let's look at this graph. So if the price goes up by 8%, quantity goes up by 16%, then you can calculate that the price elasticity of supply is 16% divided by 8%, so it's 2. And again, we're using the midpoint method to calculate percentage changes to avoid this difference between going from point A to point B and back from point B to point A. So just like we have different demand curves, we can also have different supply curves. So if the supply is unit elastic, that means price elasticity equals to 1. And if supply is elastic, price elasticity is greater than 1. And if supply is inelastic, price elasticity is smaller than 1. And just like you have perfectly inelastic or perfectly elastic demand, you could have perfectly inelastic supply and perfectly elastic supply as well. So here, perfectly inelastic supply, you would have price elasticity to be 0. And so you have a vertical supply curve. So the price has no effect on quantity supplied. And if it's perfectly elastic, you have a horizontal supply curve. And so price elasticity of supply is infinity. Just like price elasticity of demand reflects how flat the demand curve is, so price elasticity of supply reflects how flat the supply curve is. So the flatter the supply curve, the larger the price elasticity of supply. All right, let's take a look. So a vertical supply curve is perfectly inelastic supply. So when the price goes up by 10%, quantity supplied does not change. So you have price elasticity of 0. You have a vertical supply curve. Sellers are not sensitive to prices at all. Elasticity is 0. And so when you have inelastic supply, it may not be a vertical supply curve, but a quite steep supply curve. So when price goes up by 10%, quantity goes up by less than 10%. So this means that you have a price elasticity that is smaller than 1. And so you have a relatively steep supply curve. Sellers are not sensitive to prices. Elasticity less than 1. And if you have unit elastic supply, that means that when your price goes up by 10%, your quantity supplied goes up by 10% as well. So your price elasticity of supply is 1. So you have this unit slope, intermediate sensitivity to prices, and elasticity is 1. And if the supply curve becomes flatter and flatter, you have elastic supply, where if the price goes up by 10%, the quantity supplied goes up by more than 10%. And so you have a price elasticity that's above 1. And so sellers are relatively sensitive to prices. You have a relatively flat supply curve. And if your supply curve becomes flatter and flatter and flatter, and the limit, you would have a perfectly elastic supply. Before you hit the limit, the slope is still positive, so it's still upward sloping, but it's almost flat. What that means is that if you increase the price by a little bit, quantity supplied basically blows up like crazy. And so that means you're extremely sensitive to prices. So you have a price elasticity of supply of infinity. And so you have a horizontal supply curve. So one thing you should note here is this. So the extreme case, in the limit, you have a horizontal supply curve. But so before you reach this limit, it's still upward sloping. In that sense, that's how you understand a perfectly elastic supply. So when the price goes up by a little bit, well, quantity supply blows up to infinity. Yeah, so that's the extreme case. The flip side is perfectly elastic demand. In that case, you have a horizontal demand curve, or in the limit. And remember, the law of demand says the demand curve should be downward sloping. So the perfectly elastic demand, in the limit, it's a horizontal demand curve. But before you reach that limit, you can think that, so it's still downward sloping, but almost flat. There, when you drop the price a little bit, quantity demanded goes up by a lot, by infinity. So the buyer is extremely sensitive to prices. Even though we say that the perfectly elastic demand curve and the perfectly elastic supply curve are both horizontal, well, it's in the limit they're horizontal, but one is approaching from below, one is approaching from above. So to understand why we think you're extremely sensitive to prices, you have to think about a almost flat but still downward sloping demand curve, or a almost flat but still upward sloping supply curve. All right, so just like you can talk about what determines demand elasticity, here we're also going to talk about the determinants of supply elasticity. When you have higher price elasticity of supply, that means the sellers can change the quantity that they produce more easily. And so, for example, in the short run, you might not be able to adjust production that quickly, but in the long run, you can adjust more. So price elasticity of supply is greater in the long run compared to the short run. So think of, like, say, Apple producing iPhone 13. Well, in the short run, it can tell Foxconn to hire more workers and try to crank up production. Of course, now, recently there was this electricity outage. Well, then they may not be able to run 24 hours a day. So in the short run, you can try to increase production, but maybe not that much. But in the long run, you can say, hey, you can build a new factory. Well, if there's an electricity outage, well, build a power plant. Foxconn has been building literally cities in China to produce iPhones. So in that sense, in the long run, the sellers can adjust and they can change the quantity they produce freer than in the short run. So price elasticity is larger in the long run compared to the short run. I think somebody asked on Slido about the price elasticity of demand in the short run versus long run. And I think the same thing applies here. So in the short run, you cannot adjust with that many ways. Or for most adjustments that you can do in the short run, you can also do in the long run. But there are some adjustments that you can only do in the long run. In the case of companies or producers, well, firms can build new factories, they can have new firms enter the market or exit the market. But in the short run, these adjustments will not happen immediately. Similarly, on the consumer side, well, in the long run, you can choose to relocate or to buy a car or buy a hybrid car, electric car, or you can even say, I want to take the Uber all the time instead of owning a car. So these decisions would happen in the long run and are unlikely to happen in the short run. And because you are more flexible, you have more options to adjust in the long run, so price elasticity is always larger in the long run compared to the short run. Okay, think about residential apartments and pork. Now assume that the supply for residential apartments is inelastic because, well, there's only a fixed amount of land and it's not easy to find new land to build. But the supply of pork is elastic because you can adjust how many pigs that you want to slaughter each day in response to the price change. So suppose the population growth causes demand for both goods to double. So that means that at each price, quantity demanded is doubled. Which product would have a price change that's larger the most? Which product will quantity change the most? And so we can draw a graph with the new equilibrium in the market of housing and in the market for pork. Okay, so prepare to join the quiz. So assume that the residential apartments is inelastic. The supply for pork is elastic. Suppose population growth causes demand for both goods to double. Which product will price change the most? Residential apartments, pork, or don't know? You have 10 more seconds. Okay, so here are your answers. So residential apartments is the majority answers. Some of you say pork. Let's take a look. Residential apartments is correct. What about quantity? So again, the same situation. For which product would quantity change the most? Residential apartments, pork, or don't know? You have 10 more seconds. Okay, so the majority of you overwhelmingly say pork, and that is the correct answer. Okay, so when supply is inelastic, the increase in demand would have a bigger impact on prices than on quantity. So here you have this example with inelastic supply, a steep supply curve. When the demand curve doubles, so at each price, quantity demanded is doubled. So you have a huge effect on prices because of the steep supply curve, but a relatively small effect on quantity. So think about residential apartments. Well, supply is inelastic. It's very hard to find new land to build more apartments. And prices go up like crazy when population growth causes the demand to double. In some sense, that's exactly what's happening in Taipei City, right? I mean, the population is growing and housing prices go like crazy. Think about pork. Here we assume that you have elastic supply. So the increase in demand has a bigger impact on quantity compared on prices. So when you have a flat supply curve, when demand is doubled, prices go up, but not that much compared to quantity. Even for the same product, you can have, like say in this case, the supply curve is not a straight line. So you could have elastic supply when quantity is small. So like here, when the price goes from $3 to $4, quantity supplied goes from 100 to 200. But when quantity goes up and up, you can have an inelastic supply. In this example, even if prices go up from $12 to $15, quantity supplied only goes up from 500 to 525. Usually this is the case, especially if you have capacity constraints. So you can only supply that much because your factories are already running 24 hours a day. Even if you want to, if you're facing a higher prices, cranking up production is not that easy. Given Apple just launched iPhone 13, I wonder where its production is. But my guess is that Foxconn has been cranking up production like crazy because this new launch is creating a lot of splash and demand for the iPhone 13 is high. But you can think, because of the outage, well, you can think that maybe it's very easy for Foxconn to hit the production capacity constraint. And so there you could just have a problem where elasticity is small. Okay, so now we'll look at some more applications. Can good news for farming be bad news for farmers? So think of some agricultural innovation. So you have this new hybrid of wheat where you could produce 20% more per acre. So you're shifting the supply curve to the right. What does that mean? Well, quantity is going to go up because of production, but prices are going to go down. And here's the problem. If demand is inelastic, well, the quantity effect is dominated by the price effect. So the huge price drop compared to the small increase in quantity is going to cause total revenue to go down. And if the per acre cost of production is the same, then total profits would go down. Of course, that is an assumption because a drop in revenue does not mean a drop in profit if cost is also going down. But here, if we assume that the cost is the same, well, then a drop in revenue would actually cause your profit to drop as well. So the irony here is that you try to have some agricultural innovation, hoping to help the farmers, but it's actually going to reduce the revenue and hence the profit of the farmers. So good news for farming, but bad news for the farmers. Some of the farmers might say, hey, I might as well stop planting these crops because it's not worth it anymore. So and remember here, the key thing here is that we're assuming that demand is inelastic. And hence, the drop in prices is larger than the increase in quantity demanded. And of course, if we have an elastic demand, then we have a different story. So it really depends on whether or not here the demand is inelastic or elastic. But as we saw, well, rice, for example, the numbers are you have inelastic demand for rice throughout various countries in the world. So this could be a real problem. Okay, so let's take a look at this. So here, this is the market of wheat. Say the price of wheat is $3 and quantity is 100. So an increase in supply, so your supply is going to shift to the right. But if the demand is inelastic, you'll have a huge drop in prices, but a relatively modest increase in quantity. So in this case, price dropped from $3 to $2. That's a huge drop. But quantity demanded only went up by 10. So the original revenue is $3 times 100, which is 300. But now it's $2 times 110, so it's only 220. Total revenue is going to go down. Okay, the next application. So why did the OPEC fail to keep the price of oil high? So what is the OPEC? The OPEC is this cartel of countries that produce petroleum or produce oil, and they basically try to set the prices and set quotas for each of the countries to try to keep the price of oil high. In fact, they were successful in the 70s. The oil price skyrocketed. That's a big problem back in the 70s. And here's the thing. Suppose nobody expected this, and the oil price went like crazy. What can you do? Yeah, you can do some adjustments to reduce consumption on oil, but not that much. And because of this decrease in supply would have a huge impact on prices, because you remember this is inelastic supply and demand. But in the long run, when people can adjust, so if the prices are high for long, Well, new oil fields could be discovered. Actually, the US is now the biggest producer of oil in the whole world because the high oil prices have induced different companies to discover new ways to produce oil in the US. And similarly, on the demand side, consumers can say, oh, maybe I should switch to a more gas-efficient car, hybrid car. Maybe I should buy the Toyota Prius, or even go to Tesla, electronic car that would not be affected by gas prices at all. And of course, what that means is that when you have a decrease in supply, because of the inelastic supply and demand, you have a smaller increase in prices. And of course, that really depends on how elastic or how inelastic supply and demand are in the long run versus in the short run. Like the data we saw, the price elasticity of demand for oil is still smaller than 1, but it's better in the long run compared to the short run. Okay, let's take a look. So in the short run, you have a relatively steep supply curve and demand curve. And so when you have a supply shock, you shift the supply to the left. So here, what you get is a huge price effect because prices are going to go up like crazy because of your steep demand curve. So in that sense, reducing supply in the world oil market is going to have a huge effect in terms of increasing prices. But in the long run, when the oil market has flatter supply curves and demand curves, even if you have the same shift in supply, well, you would have a much smaller price effect compared to in the short run. So the effort of the OPEC to try to reduce supply had a huge effect on the oil prices and the oil market in the short run back in the 70s. But in the long run, this effect is much smaller. All right, so think about the Taiwanese government. To reduce teenager smoking, they decided to raise the cigarette tax. Suppose the government says, okay, let's impose a $20 per pack tax on cigarettes. After 1 month, the quantity demanded for cigarettes have reduced only slightly. Suppose you and 2 other colleagues work for a cigarette company. Discuss the following. What conclusion can you draw about the 1 month demand for cigarettes? 2, Caleb, one of your colleagues who also work in the same cigarette company, says the cigarette industry should get together and raise the price of cigarettes further to increase total revenue. Well, do you agree with that? And your other colleague who works also in the same company, so Keisha, says only your firm should raise the price of your cigarettes to increase total revenue. Do you agree with that? Why or why not? So now this is an active pool. The government places a $20 per pack cigarette tax in order to reduce teenage smoking. After 1 month, you see that quantity demanded of cigarettes have been reduced only slightly. What conclusion can you draw about this 1 month demand for cigarettes? So I think this is an open-ended question. So we'll see the word come. Quite a few have already answered. You can still type. Okay, here you see in the word crowd, the majority of the response is about the demand for cigarettes is inelastic. Yeah, so if you think of it, Cigarettes is an addictive good. So even if the price now goes up by 20 NT dollars, well, would a smoker go to the convenience store and say, oh, it's so expensive, maybe I should not buy it? Well, unlikely. It is true that in the long run, things could be different. But if you look at only 1 month, it's really the short run, the immediate response. So if you think of it in the short run, and remember, I mean, people might not even notice the price increase because it only happened 1 month ago. If you watch the news every day, then you might be catching that. But if you're a student studying for the midterm, you might not notice that. And you say, oh, hey, why is it so expensive? Or is it that if you only happen to have certain amount of cash to buy your cigarette, and then you give that amount, and then the store clerk says, sorry, you need to pay 20 more NT dollars to get this. You say, oh no, I don't have my cash. What should I do? And then you realize that, aha, there's this price change. And if you think of it, it is true that compared to the actual price of each pack of cigarette, 20 NT dollars may not be that much. But the key thing is that if the percentage change in prices is larger than the percentage change in quantity demanded, you have an inelastic demand. So if the quantity demanded does not change at all, I mean, even this modest price increase, it's not tiny, but it's not huge. But even the modest price increase changes quantity demanded by very little. So you see how demand for cigarettes is inelastic. Okay, so next one. So you and your colleague work for a cigarette company. Discuss comment from one of your colleagues, Caleb. The cigarette industry should get together and raise the price of cigarettes further to increase total revenue. So do you agree with this or disagree? I believe this is also an open-end question, so you can put in your responses. All right, so a lot of you have entered your answers. If you still have answers, you are still free to key in and send it out. So the first thing is that, yeah, at least in the short run, demand is inelastic. So if the whole industry can raise the price of cigarettes together, then total revenue will go up. However, remember, number one is that in the long run, demand will be more elastic compared to the short run. So you can imagine that total revenue may not increase as much, and it could even decrease because of the higher price. And so that's something that you should think about. But at some sense, that's exactly the policy goal of imposing this cigarette tax. Because with the higher price, that's going to discourage teenagers to become new smokers and encourage some smokers to quit. And in that sense, it's good for the public health. One thing I do want to say is that if an industry gets together to raise the price together, that's called price fixing. We'll talk about collusion when we get to the chapter on oligopoly, but in most countries, price fixing is illegal. This form of explicitly saying, hey, let's all raise the price by this amount, that is illegal. I mean, you're just not allowed to talk about price fixing. That's not allowed. Another issue here is that if there's explicit collusion, the antitrust authorities may step in to try to do something. There's another issue that is going on. But of course, you can say, maybe we can implicitly increase the prices. If you think of the gasoline prices in Taiwan, you see a very interesting pattern because there are two major companies that sell gasoline in Taiwan, and their prices change almost simultaneously. So whenever one company increases the price, the other also increases it. And one drops, the other also drops. And so you see this strategic interaction between them. So there could be this sort of implicit sort of cooperation. So there is a different layer of problem that's beyond this chapter about elasticity that would affect whether or not this joint effort to raise prices together is illegal because of antitrust issues. Okay, so I see a lot of evil faces in the word cloud. But I do want to say that the whole point for imposing a cigarette tax is to discourage people from smoking. So in this respect, even if the industry get together to raise prices, well, you are still achieving the goal that quantity demanded will go down. Of course, you can talk about other issues, whether it's fair or whether it's against the antitrust laws. But the bottom line is that this is a way to achieve your policy goal. Is it the best way is debatable. Okay, and the last question. So your other colleague, Keisha, says, only your firm should raise the price of your cigarettes to increase total revenue. Would this work or not? Agree or disagree, and why? Okay, so we have a stupid idea. Okay, so I see a lot of huge disagree. But the question is, why would this not work? What's the problem here? Okay, so quite a few have already typed in your answers. So there's a lot of disagreement about Keisha's comment. And where's the catch? I mean, the other comment is the whole industry increasing prices. This one is your company increasing prices. And the key issue here is whether or not your product, your cigarette, is that different from other cigarettes. Because if your cigarette has close substitutes on the market, when you increase your price, what would you do? Well, consumers will switch to other brands, to other cigarettes, because these are close substitutes. If there are not that many substitutes, then of course your strategy may work. Just like when we talked about at the very beginning about, like, say, Samsung S21 versus the iPhone 13 Pro, if the iPhone has a price increase, fewer consumers would switch to other smartphones because there are not that many smartphones that are close substitutes of an iPhone. Maybe the iPhone 12 is a close substitute of iPhone 13. But beyond the iPhone, it's not easy to find a close of this product. Compared to that, like cigarettes, does it really matter if you're smoking Marlboro or Changshou or whatever brand? Too bad, I don't smoke, so I have little idea about the brands of cigarettes. But if you're a smoker, does it really matter that much? Depends, right? I mean, some people like this flavor or that brand, so it depends. But at least some of the customers might find that, so smoking other brands are similar to yours. So if only your company is raising the cigarette price, what's going to happen is that you're going to encourage your customers to switch to these other brands. And of course, your total revenue is unlikely going to go up. It's more likely that the demand for your cigarette is more elastic compared to the demand for cigarettes in general. Actually, that's the first quiz question we talked about, Mountain Dew and soda. It's similar to that. So maybe doing this is a bad idea. Okay, so up to here, these discussions are mainly done as workers in the cigarette company. You can think of a different perspective, like say a public health agency from a governmental standpoint. What do you think is better? All right, so to summarize, so the price elasticity of demand, that's the first thing we talked about. So this measures how the quantity demanded responds to the change in prices. And so it's the percentage change in quantity demanded divided by the percentage change in prices. We have inelastic demand if it's smaller than 1. We have elastic demand when it's greater than 1. Here, when we say greater or smaller, we're talking about the magnitude or the absolute value, because for the law of demand, we know that price and quantity demanded go in opposite directions. And so we talked about why demand will be elastic. It's because there are close substitutes. It's a luxury rather than a necessity. The market is more narrowly defined, or if buyers have enough time to react, like in the long run. And total revenue is affected by this because, well, when you have inelastic demand, it will move the same direction as the price change. But if you have elastic demand, it will go the opposite direction of a price change. And then we have income elasticity of demand and cross-price elasticity of demand to see how quantity demand is affected by the change in consumer income and about the change by another product. And we use this to apply this to talk about the market of wheat, for oil, for illegal drugs. And then we move to the price elasticity of supply. So this measures how quantity supplied responds to changes in the prices. And so this is the percentage change in quantity supplied divided by the percentage change in prices. And just like we have elastic or inelastic demand, we have elastic supply if price elasticity is greater than 1. And we have inelastic supply if price elasticity is smaller than 1. And in particular here, we talk about the short run and versus the long run. Price elasticity is larger in the long run. Okay, so here's my one-page summary. We talked about different types of elasticity: price elasticity, income elasticity, and cross-price elasticity. So there are some homeworks from Mankyu's textbook, but also we have a whole bunch of challenge questions. One thing I should note is that I've been teaching since 2007. I think I've asked a question each and every midterm. That's how much I love this chapter. So that's the main challenge. Okay, so here we have first question. If a person is rich enough to afford Rolex, wouldn't he be less bothered about the change of price? The question here is, what are the consumers of Rolex? Suppose a second-hand Rolex is for sale. It's cheap enough that even you and I can afford. Would you buy the Rolex? The key thing here is that how sensitive is the group of potential consumers of this good. And of course, I mean, if the Rolex is going to go from $1 million to, like, say, $500,000, very few people in the classroom will be able to afford it, and so it doesn't matter anyway. But if the price drops to a range that you and I would consider, then are we sensitive to the prices? Yeah. This is an empirical question. I mean, how low would the price need to drop so that people would start to respond to that? Well, I mean, that depends on your income, my income, and the income of the whole society. Okay, so how can we be certain that Samsung has more close substitutes than iPhone? Maybe Samsung offers special features like Samsung Pay so that people are stick to it. Yes, this is an empirical question. Well, but the facts are the iPhone has Apple Pay and it's even more special than Samsung Pay. So at least in terms of this dimension, well, both of them have offer special features. And actually, I think more stores accept Apple Pay than Samsung Pay. So this is an empirical question. Well, you look at the real world and you would find the data and figure out that, yeah. So actually, economists have been doing this. The empirical I/O people, they try to estimate the demand for different products. And what you do see is that there are more close substitutes for Android phones compared to the iPhone. The Rolex question, isn't a Rolex watch a superior good? Okay, yeah, so a Rolex watch is usually a normal good. So the higher the income, the higher the demand. But the key thing here is that it's a luxury. It's not a necessity. So the question is, are consumers sensitive to the price, fixing their income level? Are they sensitive to the price change of the Rolex? Suppose Rolex has like a Christmas special, 10% off. So would that affect quantity demanded of a Rolex? So if it's a luxury, well, when the prices become people are relatively sensitive to the price change. So in that sense, the demand for Rolex is elastic. But it could be that a Rolex is viewed differently by the rich people, and so things could be different. Next one. When the oil price changes, won't people expect it to go down, so buy less? I think buying a small car or move closer isn't a substitute that is easy to fulfill. Yeah, so the first thing is that, so in the short run, what you could do is to try to shift consumption. So if you are an oil field owner, you can say, maybe I should sell more. Yeah, if I'm a buyer, I could try to store some oil. But if you're talking about gasoline, well, your car has one tank. And so if it's close to empty, you have to refill. I mean, there's not that much that you can shift. You can shift, like, say, a day or two or a week or two, but it's not easy to store oil or to store gasoline in your home or in your backyard. But it is true that buying a smaller car, moving closer is not easy. That's why these are responses that are only possible in the long run. So if you plan about buying a car, usually this is like once every year, once several years. I mean, it's not like you buy a car like every month or every week. Well, I mean, it depends. I mean, if you live in a dormitory, maybe you have to move every year. But it's not like you're moving, you're relocating like every week or every day. And yeah, so these are long-term decisions. Yeah, so these are not easy to fulfill, but these are options that are available in the long run, but they are not available at all in the short run. Okay, for the gasoline long run, short run, why can't it be short run that drop? If there's a long run, people would choose the one that is more effective. I'm not 100% sure what this question is about. The key thing is that in the short run, people have less ways to adjust to a price change in gasoline. But in the long run, they have more options so they can adjust to the gasoline price. So if the prices become cheaper, then they can shift to buy larger cars or to drive longer routes. But if it's more expensive, they can choose to say take the MRT or move closer to where they study or their work. If the long run and the short run had the same percentage, but people would most likely bought the long run instead of the short run, so demand would drop. Yeah, so in the long run, you have more options. So quantity demanded in the long run would drop more if the price goes up. compared to the short run, where you have less options to adjust. How to know the shape of the PPF supply-demand curve, bend or a straight line? Okay, good question. I think the general answer is that it's unlikely a straight line in reality. But for illustrative purposes, you draw a straight line to make it simple. But usually it's not a straight line. Let's actually go back to that slide to see this. So the price elasticity of supply is large with smaller quantity. But when quantity goes up, supply becomes less elastic. So here you actually see that the supply curve is not a straight line. It's curved to be flatter with lower quantity, but steeper in the end. In some sense, drawing a straight line, that's a simplification. That's usually not true. And I think in chapter 2, when we talked about PPF, we also said that, yeah, because of the opportunity costs and the competitive advantage within a society, the PPF is usually not a straight line, but a curved. Okay, so can you explain the perfect elasticity again? So I think I tried to explain this when we went to the supply side as well. But the key thing is that from the law of demand, we know that the demand curve is downward sloping. But when it becomes flatter and flatter, in the limit, it will be horizontal. But think of right before you get to that, you have a very flat demand curve. That means when the price goes down a little bit, quantity demanded just explodes. If the price goes up a little bit, quantity demanded will just shrink to zero. So that's like an extremely sensitive demand curve where prices change a little bit, quantity demanded like swings back and forth like crazy. So that's what we call a perfectly elastic demand. And on the supply side, it's the opposite. The law of supply says that we have an upward sloping supply curve, but when it's flatter and flatter, so in the limit, you get a horizontal supply curve. But what that means is that before you get to the horizontal, it's still upward sloping. But so when the prices change a little bit, again, the quantity supplied blows up to infinity or goes to zero very quickly. Yeah, so that's the extreme case where the suppliers are like ultra sensitive to prices. Okay, if we take the absolute value of price elasticity of demand, how should we understand the elasticity of given goods? That's a very good, yeah. We're actually not going to talk about given goods in this class. So when you go to intermediate microeconomics, you will talk about given goods. So it's a violation of the law of demand. So actually, you see that when I got the price elasticity numbers from Wikipedia, they come with a minus sign because in general you could have you could have given goods where you actually have a positive price elasticity of demand compared to the normal negative price elasticity of demand. Yeah, but yeah, it is true that if we only talk about the magnitude or the absolute value, then so we're not talking about given goods here. So how do we know whether a product is a superior good or not? Wait, so I think we have an inferior good and a normal good. So I assume you're talking about a normal good. To really know whether a product is a normal good or an inferior good, you have to measure the income elasticity of demand. Actually, that's exactly why we have this chapter. To measure these elasticities, that's how you figure out if this is a normal good or inferior good. Are these substitutes or complements? I mean, that's an empirical question. In the case of drug-related crimes, is it possible for the demand and supply analogy to be too simplistic? Very good question, yeah. Actually, if you think of illegal drugs, are all illegal drugs the same? Well, that itself is a question. Some people view amphetamine or like a heroin. Actually, what I'm not sure about is cannabis, because in some places cannabis is legal, other places it's illegal. And then, of course, drinking alcoholic beverages is illegal in some places, but not others. So using a simple supply-demand model to analyze this is likely too simplistic. Well, at some sense, that's the whole point. I mean, just like if you think of chapter 2, chapter 3, where we have only two countries or two goods, that is a simplification. And of course, using models, you are making assumptions, trying to abstract away from the complicated reality. And so it is true that the next step is to think about, so is the supply-demand model the right model that would capture features of this complicated case of drug-related crimes? And so maybe it's not. So that is something that you should think about very carefully because, But the first step is that, okay, suppose we use this, we're making simplified assumptions, but what do we get out of it? Then we can say, okay, so are these assumptions realistic or not? What if we change the assumptions? Actually, in the second half of the course, we will talk about what we call homogeneous goods versus non-homogeneous goods or differentiated products, where you will talk about similar but not identical goods. And of course, I think that would be a better description of, like, say, these illegal drugs. Okay, so maybe one of the other factors could be that there's more agents to find drug-related criminals, and the agents just found more. So there's one issue here is that, are you cracking down on the drug dealers, or are you cracking down drug users? So in the example we gave in this chapter, the key thing is that these agents are going after the suppliers or the sellers, the drug dealers, and that would shift the supply curve. And of course, you can think of what happens if the agents are going after the buyers, the consumers instead. And of course, that would be a different situation. Does that mean that increasing the supply of drugs can cut down on drug-related crime? At least more effective than curbing the supply? Yeah, so one thing that's counterintuitive is that in the war on drugs, actually providing the drugs could be a solution. Actually, one of the main ways that people deal with this heroin addiction is actually to give these drug addicts a substitute to heroin. That's actually, so there is a medical substitute for heroin. The Taiwanese government is actually giving this out for free to these drug addicts. And yes, it does actually cut down drug-related crime, because instead of committing these crimes to get a lot of money to buy these drugs, they just go to the hospital and take this substitute for free. So in that sense, you think, wait a minute, is that right? The key thing is that, well, in this case, actually, this substitute is medically proved to be a substitute, and it's not bad that bad for your health compared to consuming heroin, and so yeah, so it's actually approved to be administered on these people. So in this sense, actually, that's good. Actually, some of the economists, they even advocate that maybe you should legalize everything, because that actually helps in that sense. So yeah, but anyway, so whether or not that's good or bad, this part is a normative debate, and so it depends on various value judgment. But in terms of positive issues, yeah, so it is true that if you increase the supply of the drugs, especially because your demand is inelastic, you could actually cut down drug-related crime. So I'll stop here, and thank you very much.